Hi, I'm Kigo Kawamura. In this lecture video, I will explain how to calculate the number of the combinations for the group of objects using the permutation formula. Fundamental principle of counting. Theorem. If the first element of an ordered pair can be selected in n sub 1 ways, and for each of these n sub 1 ways, the second element of the pair can be selected in n sub 2 ways, then the number of the pair is calculated by n sub 1 times n sub 2. Yeah, it is obvious. Let's see the following examples. Examples. A homeowner doing some remodeling requires the service of both the plumbing contractor and the electric contractor. If there are 6 plumbings and 4 electric contractors available in the area, in how many ways can the contractor be chosen? Okay, so this is 6 times 4 equals 24. Easy. Permutation and combinations. Let me start with the following question. Suppose there are 5 tickets in the box. 3 tickets are drawn without replacement from the box. First question. If the order is important, how many possible triples of the number can we have? Okay. Solution. Since 3 tickets are drawn without replacement, calculation has to be 5 times 4 times 3 equals 60. Let's generalize this. If the number of the cards in the box is n, and the number of the cards you drawn is r, the answer is n times n minus 1 times n minus 2 times n minus r plus 1. Well, this formula is called permutations. Permutation is just a specific case of the fundamental principle of the counting. Next question. Suppose there are 3 tickets 1 to 3 in the box, and 3 tickets drawn without replacement from the box. If the order is not important, what is the number of combinations? Okay, let's listing up. 1, 2, 3, 2, 1, 3, 3, 2, 1, 1, 3, 2, and 2, 3, 1, one more, 3, 1, 2. Is that right? Yes, 6 different cases. However, if the order is not important, it has to be counted as only one group. So I can just say 3 times 2 times 1 divided by 3 factorial is equals to 1. Let's generalize this. If the number of the cards in the box is n, and the number of the cards you draw is r, then the answer is n times n minus 1 times n minus r plus 1 over r factorial. Okay, this formula is called combinations. Combination is taking an order out of the permutations. It may be nice to memorize this formula so that you can calculate by hand. TI-83 calculator has a feature to calculate combination instantly. If you don't have a graphing calculator, you can use factorials or else Pascal's triangle to obtain the binomial coefficients. Exercise 1. Suppose we have 40 students and I'd like to ask 3 different students to work on 3 different practice problems, and each student will present a solution to the corresponding problem. How many different ways can I assign these problems? Solutions. First, ask whether the order is important. In this case, yes. So, use permutation. Permutations. 40, choose 3, that is 40, 39, and 38, which is 59,280. Exercise 2. Choose 2 different dates from the Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday to go swimming. How many possible choices can we have? Solutions. Again, ask if the order to choose is important. In this case, no. So use a combination. So in this case, 6, choose 2. That is 6 factorial over 2 factorial, 6 minus 2 factorial, 6 factorial over 2 factorial, and 4 factorial. 6 factorial is 6 times 5 times 4 factorial over 2 factorial, 4 factorial. You can cancel out here, so that would be 15. Exercise 3. A department in the company has 12 members, 8 males and 4 females. To gain greater insight into the employee's view of the various benefits, the Human Resources Office plans to form a focus group from members of this department. 5 departmental members will be selected at random from the department member. What is the probability that the focus group will have 2 males and 3 females? Solutions. Notice that this question asks for probability. So remember, probability is given by number of favorable outcomes over number of possible outcomes. So since the order to select is not important, number of favorable outcome is 8, choose 2, and times 4, choose 3. What is the number of possible outcomes? 12, choose 5. So after calculating either by hand or TI-83 calculator, you will get 14 over 99. Exercise 4. Suppose a class of 4 boys and 5 girls is to attend the graduation ceremony. First question. How many ways are there to order the students so that boys and girls alternate? Solutions. The only way to let all boys and girls sit alternate is go, boy, go, boy, goes, boy, go, boy, and go. Let us choose the girl to sit in each spot. Well, 5 factorial ways we can choose. In the same way, 4 factorial ways for the boys to sit in each spot. Using a fundamental principle of the counting, the total ways are 5 factorial times 4 factorial. Second question, how many ways are there to order the students so that boys and girls sit separately? In this case, we have 2 different ways to prepare their seat. First way, go, 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 go. And boy, 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 boy. Second way, boy first, and go. Okay, so first way, there are 5 factorial times 4 factorial way. And second way is 4 factorial times 5 factorial way. Therefore, the total ways to let the boys and girls sit separate is 2 times 5 factorial times 4 factorial. Done! See you next time!